Hello, in this video I will talk about how I code trigonometry functions with only iterations and basic operators. I'm CCIB and let's get started. For trigonometry functions, I will choose to use the sine function. You know, in maths every function that is 1 to 1 or range to 1 can be expressed as a polynomial, and it can be up to unlimited degrees. You can refer to it as a Taylor series. Here is sine x as the starting point, and we will use calculus to find the polynomial by differentiation. To find the constant term for each derivative, we apply x equals 0 to it. Then later, we use integration to find the polynomial terms. I know it can be written as factorial, but my goal is to use only basic operators. You will see a pattern here, plus minus, x to the only odd number power, only odd number factorial, which is steps of 2. I will write it as a summation, which an iteration contains a plus and minus pair. You notice that the changing number is different by 4 in each iteration, so I have to use 4n minus 3 for the plus term and 4n minus 1 for the minus term. Then we will figure out the upper limit by graph. And this is the formula. I'm using decimals to find the limit, which is the key of accuracy. I aim to make it as accurate in range minus 2 pi to 2 pi. After repeating testing, I found out that 6 iteration is close enough with uncertainty of 0.001. Now we are thinking about the codes. As it is a summation iteration, we can use the format y equals y plus or minus a over b, which a is starting with x, b is starting with 1, y is starting with 0. A is the numerator, which multiplies by x squared in each half iteration. B is the denominator, which multiplies 4n minus 3 times 4n minus 1 in the first half iteration, and 4n times 4n plus 1 in the last half iteration. Y equals y plus a over b in first half iteration, and y equals y minus a over b in the last half iteration. N is incremented by 1 in each iteration, and we are done in terms of the iterations. But before all these fancy iterations, we have to make sure that x is in range minus 2 pi to 2 pi. It can be achieved by remainder operators, because 2 pi is a cycle. So we simply mod the input with 2 pi. Now it's coding time. Using JavaScript is my personal preference, don't bully me. So, you know, because programmers are lazy, I just simply use y plus equals a over b instead of y equals y plus a over b. Why not if it does the same thing, I mean? So, let's test it. So sine 0 seems correct, but JavaScript has some problem with the decimal place, as you can see. Minus 1e minus 13 is a very small number, so let's pretend it's 0. So there seems to have no overall problems after all, except for the JavaScript decimal problem, but it was promised that it will be accurate to 4 decimal place, so it's fine. If you wonder how I do the other trigonometry functions, you can simply adjust the sine functions with trigonometry identities, like cosine x equals to sine x plus pi over 2, tangent x is sine x over cosine x, cotangent x is 1 over tangent x, secant is 1 over cosine, and cosecant x is 1 over sine x. That's all. If you like this video, don't forget to like, subscribe, and comment down your thoughts. I'm CCIB. See you guys. Bye.